Assalamualaikum. Good day, Dr. Noiza. So today we are from Group B, consists of 3 members, me, myself, ASMA IZNI, Nurul, Atiqah, and also Nur AISHAH. So today we're going to explain about porous component which is in self-lubricating bearing. So this is our outline today. We have introduction, raw material and its properties, design, fabrication technique, testing and analysis, final product, benefits to industry, and also conclusion.
So, for introduction, powder metallurgy is a manufacturing process which is converting raw material into fine powder particle by the process of blending, compacting, and saturating in a controlled atmosphere. So, according to MS 2021, Figure 1 shows the powder metallurgy process. It includes powder, mixing or blending, compacting, and sintering. Next. So, in this assignment, we are assigned the title of porous metal component. Porous metal component having a large volume of porosity between 35 to 80% of porosity volume. It known as a strong and lightweight material due to the formations of interconnected porous structure. Self-lubricating bearing is one of the porous metal component application. It widely used in many as its impregnation in oil to provide constant lubrication between bearing and shaft. Figure 2 shows example of self-lubricating bearing. It shows that there presence of lubricate between the space of bearing and the shaft. So in this assignment, we will explain in detail on raw material use, manufacturing of self-lubricating bearing, design of part, fabricating technique, testing analysis, final product, and lastly, benefit to industry. Next.
Okay, so next is raw material and its properties. So most porous metal bearing are made of bronze or iron with interconnected parts. So bronze bearing are very porous and have lightweight oil soaked into the material. So the self-lubricating bronze bearing is made up of metallic components that have a porosity rate of nearly 25%. So a high porosity rate means that liquid can be transferred easier. So bronze powder consisting of 90 to 92 weight% of copper and 8 to 10% weight tin is the most common material for a porous bronze powder metallurgy component such as filter and self-lubricating bearing by Newbing 1986. So next. So bronze bearing have a wide range of qualities including strength, ductility, hardness, wear resistant, anti-seizing qualities, low friction, and the ability to conform to imperfection as well as the capacity to withstand filthy operating conditions and polluted lubricants. So the first property is corrosion resistant, it is particularly significant in bearings that work in harsh environment or that are idle for lengthy periods of time. So they need a proper corrosion resistant materials. So it is because corrosion resistant improve both service life and shelf life. So bronze bearing has better corrosion resistance than other bearing materials and can be chosen to suit specific environmental conditions. So bronze bearing is the good material as it is high corrosion resistance. So next. Next is the basic frictional qualities of a material, which are especially essential during those brief moments when the bearing is operating in the boundary mode. So bronze has a frictional coefficient of 0.08 to 0.14 when compared to steel. The frictional coefficient can range from about 0.12 to as high as 0.18 to 0.3 during wear or when there is no lubrication available. So finally is conformability, which is it would be extremely difficult and expensive to manufacture a crankshaft and a set of bearings with no significant misalignment between the bearing. So this problem is solved by making the bearing alloy so soft that it can deform plastically on assembly and early running, and thus accommodate any initial misalignment. This attribute of the bearing is known as conformability. So bronze bearing, on the other hand, offers such a diverse range of material qualities that one of them will almost always meet the requirement of given designs. So next, this is the design for the bearing. According to Liu 2015 state that common design for self-lubricating bearing consists of two parts which are bearing and bushing. So figure 1 shows the design for bushing and bearing. Next.
So next is fabrication technique. So the figure shows the flow charts of self-lubricating bearing. So the raw material used is bronze. So next is water atomization process at pressure of 18 MPa. Blending process using molybdenum disulfide as a binder. Compaction process at 400 MPa pressure. Centrifugal process at temperature of 800 Celsius. And lastly, post-centrifugal operation. Next. So first in powder manufacturing using a water atomization process. So it is most common method in producing the powder, which is conversions of molten metal to the powder. There are three stages, which is melting, atomization, and solidification and cooling. So figure 3 shows the water atomization process. It shows that the melted water is dropped into the chamber, and then the water jets are push to the multimeter. Next. So the process a stream of molten bronze is emerging vertically from a two flat stream jet located opposite side of the molten bronze stream into the atomization chamber. After passing the chamber, the molten bronze is disintegrated by the impact of high pressure water jets at 18 MPa. Then the powder is separated by the water, and here the cooling and solidification process take place. So figure 4a show the water atomization process. As you can see that the molten metal are poured through into the chamber, and then the water jet hit the molten metal and becomes the particle and drop at the bottom of the chamber. So the higher the cooling rate, the more the irregular shape produced due to this integrated high water impact. And the particle hit each other that form the irregular shape. So figure 4b show the bronze particle in the irregular shape. Next is blending process using a molybdenum disulfide as a binder. So figure 5 show the V-type powder blending, and it show the bronze powder are blending with the binder. So the process is combinations or intermixtures of powder with the same material but different particle size. Binder is added to improve the flow characteristic and compressibility of the mixture. Molybdenum disulfide acts as a binder that added into the blending process of self-lubricating bearing. This process is carried out under controlled condition which to avoid contamination. Next. For compression process, use automatic compression presses at 400 MPa. This process involves 3 stages, which is powder filling, applying pressure, and ejection of compact from die. So figure 6 show all the 3 steps involved. So the compact obtained are called green compacts. The grain strength affected by the compression ratio. The greater the compression ratio, the higher the grain strength. Next. For sintering process, we use continuous mesh bed furnace. The atmosphere is hydrogen gas atmosphere. There are 3 chambers, which is preheating, sintering, and cooling, which are joined in tandem. The cooling section is surrounded by the water jacket. During preheating, the purpose is to remove the lubricant and air, which interfere with the bonding process at temperature of 400 Celsius. Next, sintering at 800 Celsius is used where the solid state diffusion and bonding are occur. So last stage is cooling period, which operated in controlled atmosphere with oxygen-free condition to avoid decomposition process, and the presence of oxygen can ignite the burning process. Next. The figure 7 show the continuous mesh bed furnace, which consists of 3 chambers, which is preheat, sintering zone, and cooling zone. Next. So in sintering process, there are formations between adjacent particle of bronze, which shown in figure 8. As the temperature increase, cohesion takes place as net grow at the points of particle contact by the diffusions. The distance between the particle decrease and the particles become bonded. The pores become more nearly spherical and the parts tend to shrink and increase in density. The increase in density results in increase in strength and the change in dimensions. Next. And lastly, the post-sintering operation includes sizing and impregnation. Sizing is a control the dimensions of bearing within tolerances, which operated by the forcing the part into a die of smaller dimensions and forces. Impregnation is to filling the pores in the part with oil with the external pressure of 4 to 5 atm, and the pressure is brought to 1 atm until the oil is drained. And the oil used for self-lubricating bearings is silicone oil. Next.
So I will continue for the testing and analysis for this self-lubricating bearing. Basically, when installing this bearing in the housing, basically, can you hear?
Okay.
Okay, I will continue for the testing and analysis for this self-lubricating bearing. When installing this bearing in the housing, their compatibility with the lubricant must be tested beforehand. RUSLAN has stated that sintering bearing usually have a pore volume of 15 to 30%, and these pores are used as an oil reservoir for the bearings and tire service line. Commonly, mineral and synthetic oil are used for lubrication in industry. So this lubricant will reach the friction area via the pores with a system of balance developing for the bearing operation. So as we all know, lubricant are available in many forms, from high viscous lubricant to lubricant with a low viscosity. So for your information, viscosity is the internal friction of a fluid, and it is a fundamental property that describes how thick or thin an oil is. So basically, table 1 shows the properties of lubricant that commonly used in industry. So we have mineral oil and also synthetic oil. So the graph there shows the viscosity relative to the temperature for those different oil types. So many researchers explain that the flatter the viscosity temperature curve, the better the properties of the oil. But each lubricant have their own responsibility according to the environment and bearing temperature condition. As AISHAH stated that in the fabrication of self-lubricating bearings, silicone oil is the optimal lubricant that can be used in industry because it have a broad practical temperature range of negative 60 degree to 180 degree. Then it have a high viscosity coefficient, meaning that it is perform very well in viscosity to temperature ratio. According to the Levis 2007, silicone oil exhibit very low evaporation losses and suitable for very low service life at high temperature. So it is reasonable and effective to use silicone oil in many industry. Other testing analysis have been done by Ron June on 2018. They performed an experiment to verify the performance of bearing using high frequency oscillating friction and wear live test machine. So this performance parameter of friction temperature and friction coefficient are collected in real time with high sensitivity sensor. So the bearing temperature used is higher than 150 degrees Celsius, and test time to reach 400 hours as the standard of failure and termination test. So from the result, it can be seen that with the increase of cycle time, the friction coefficient fluctuate in a small range in the test process and basically maintain at 0.09. So this range of friction coefficient are suitable for bronze, which has friction coefficient around 0.08 to 0.14. So this indicates that the friction pair of the self-lubricated bearing material and chrome inner ring is easy to form transfer film on the contact surface under the condition with high frequency swing, so that the self-lubricating transfer film will maintain better supply and demand system in the whole life test process.
Okay, so next is the final product. So the final product is self-lubricating bearing as shown in figure 11. So self-lubricating bearing consists of two parts joining together, which are bearing and bushing. So bushing is where the pores is present, which impregnated with oil to avoid the friction and longer the lifespan of the bearing without maintenance. So next.
So this is benefits to industry. We have three. The first one is high lifespan. Self-lubricating bearing is known with high lifespan due to the oil present in the pore of bearing, which is to prevent the wear from occur. In aerospace industry, it requires low friction with excellent wear resistance to reduce labor cost for maintenance. The possibility of consistent bearing performance in aerospace operation can extend the lifespan of the bearing by as much as 3 times when compared to the bearing that is lubricated just once during installation. This statement according to Marcos 2016. Next, accessibility. Many areas of aircraft are difficult to access for maintenance. More times and money will be saved by optimizing the usage of self-lubricating bearing to the system, because before this, more disassemble and reassemble required to access the bearing for lubrication. The last one is for performance. In automotive industry, self-lubricating bearing are abundantly used in suspension system, which is include tire, spring, shock absorber, and linkage that connect a vehicle to the wheel and allow relative motion between these two. So it plays a very important role to make rotation become smooth and can avoid from constantly face wear.
So for conclusion, self-lubricating bearing is made out of high porosity metal component and have a pore volume to provide constant lubrication between the bearing and shaft. Analysis and testing are conducted to verify the performance of bearings such as viscosity of lubricants and the effects of friction temperature using high frequency oscillating frictions and wear life test machine. The effects of friction temperature rise has important effect on the wear life, and excessive friction temperature will accelerate the peeling off and adhesive wear of the linear material. Nowadays, self-lubricating bearings are widely used in various industries, and it provides many benefits, especially in prolonged lifespan economically, in terms of maintenance service and labor costs. So next.
I think that's all from us. Thank you.
Thank you.